Hello everyone. So today I'm recording this video to cover week 7, okay, of MECT 3360 automated manufacturing system course, and we are going to cover numerical problems from chapter 18, cellular manufacturing. Okay, and like always, I'm not going to discuss these theories, but what I'm going to cover here is, if we scroll down, the production flow analysis. Okay, so when we plan for different parts which goes through different machines, how do we group the machines and group the different parts so that we have the optimum workflow? So that is the main objective of this PFA. And there are different algorithms. Okay, so there is no standard or 100% efficiency for this arrangement of these different machines or different parts. So it depends on the user. This is all subjective. It also depends on which algorithm you choose. But here we are going to discuss the rank order clustering algorithm, right? So this one. And in this one, if we look at this example, okay, so the parts or different types of products are arranged in columns. Okay, so this represents part 1, part 2, part 3, part 4, part 5, part 6. And these letters or alphabets M1, M2, M3, M4 represents machines. So the machines are arranged in rows, okay, like these. So ideally, this is me do it here. Okay. All right. So this is the question. So for example, in this one, we can see here. Okay. So ideally, this is a column, and this is a row. Okay. So the horizontal is the row, the vertical is the column. But here, if we look at a specific machine, for example, lathe 01, so all these numbers mean something for lathe 01. So we can say that we assign the rows for a machine. Okay, so here we have a saw, here we have a lathe, and they are arranged, their numbers, their values are arranged in rows for different parts. Okay, and wherever you see 1, that means that part goes through that specific machine. All right, and if there is a blank or a 0, that means the part does not use that machine. So in slide 43, okay, so in this example, for M1, we have this blank here, which means part 1 does not use machine 1. Here, it means part 3 also does not use machine 1. And 2 uses machine 1, 4 uses machine 1, 6 uses machine 1, and so on. So depending on which parts use which machines, we are now going to arrange the machines and the parts together. And in our final solution, we will see something like this. Okay, so the ideal scene is where these 111 fits in one matrix, um, like this, and the blank spaces or the zeros fit in the other. If there is a mix between 1 and 0, that means it's not ideal, but it can be the solution, okay? So not always we can solve it ideally. Okay, so I will explain this one in more details when we look at the numerical. So right now it might be a little confusing. Okay, looking at this table or a matrix with all these elements can be overwhelming. All right, so like I said, we're going to look at the rank order clustering. So for this specific example, we can use these different algorithm. Okay, so rank order clustering is one of the commonly used algorithm. And using this algorithm, we are going to sort the order of these parts and the machines. Okay, and for each ordering, we make a new table like this, and apply some rules, and we keep on developing a new table with a new order until we get something like this. Okay. All right. So one very important thing is to apply these rules or steps. So how does this rank order clustering works? Okay, so let me switch back here. So in the rank order clustering, so the first step is to assign binary weight and add for each column the weight of the binary weight. Okay, so what is binary weight? And what is this I and J? Okay, so I is for a specific row, J is for a specific column. Okay, so if we are doing it for, let's say, column 2, then J is equal to 2. So first we select a specific column. Let's say we have these different columns here. Okay, so this is column 1, column 2, column 3, column 4, column 5. Okay, so we have 5 columns, and we want to do it for column 3. Okay, this one. So we set Z equals to 3. And for this column, there will be several rows. Okay, so when we say J equals to 3, we only look at this third column. We don't have to look at 1, 2, 4, and 5. And then we use this. Okay, so Wj means in this case we will have W3, and then summation means to add each element. But here 2 to the power I is the binary weight. Okay, so this whole thing is the binary weight. So that means if I'm doing it for first, okay, so this is I equals to 1, this is I equals to 2, okay, third row I equals to 3, fourth row I equals to 4, fifth row I equals to 5. So that means my summation goes from I equals to 1, okay, first row until I hit row 5. I stop at row 5. And then I have 2 to the power I times Mij. Okay, so here, if we start from I equals to 1, so in each of these cells, okay, we either have 1 or 0, right? So let me use different color. Let's say this has 1, this has 0, this has 0, this has 1, and this has 1. Okay, so um, so first of all, we start with this. Okay, so 2 to the power I. So 2 to the power, if we are doing it for I equals to 1, it means 2 to the power 1, because I equals to 1 times the value of that cell. Okay, so 1, because here we have 1. And why we only have 1 or 0? Because we are writing these 1 and 0 for a situation where a specific part uses that machine or not. If it uses the specific machine mentioned in the rows, then we put 1. If it does not use the machine, we put 0. So there are only two situations, okay? It uses the machine, 1, does not use the machine, 0. So for I equals to 1, we have 2 to the power 1 times 1, because we have 1 here, and this gives 2. Okay, plus, because we are doing plus because of the summation, plus for the second one, so we have 2 to the power 2, because now I equals to 2, times, now we have the element 0. Okay, plus we move to third row, so 2 to the power 3 times 0, plus 2 to the power 4 for the fourth row times 1, plus 2 to the power 5 for the fifth row times 1. And we add all of these. So this is 2, this is 16, and this is 32. So the total is 50. Okay, so W3, so for this column, the weight is 53. And we do the same for all the columns, okay? So let's say this has 60, this has 29, this has 64, this has 57, or something like this. Okay, so if we apply it for all the columns, this is what we are gonna have. And now we arrange these columns in ascending order. So the smallest at first and then increasing order, okay? So for this one, if we rearrange this column, so we will have column 2 at first because it is the smallest, okay? So column 2 at first, and then second is 3, third is 5, and fourth is 1, and fifth is 4. Okay, so now this is in ascending order. And now once we complete arranging the column, we apply the same principle for rows. Okay, so now we have finished arranging these machines. Sorry, these parts. Now we arrange the machines using the same formula. So in this case, we choose a specific row. Okay, let's say we do it for I equals to 2. And this time, okay, so W2 will be equal to, now we do it for each and every column, okay? So we change the column, but the row is fixed. So we move from 1 to how many columns we have. So total 5 columns. And we apply, okay? So 2 to the power j times mij. And we use the same technique and find the weight of each rows. And we again arrange the rows without changing the column. We arrange the rows in ascending order. And at the end, so once we do for columns and then rows, now the numbers change, right? So because for example, this arrangement is correct when the rows were not changed. So now when the rows are changed, we have to check for the columns again, if the columns have changed or not. So we have to repeat this process, okay? It's an iteration. All right, so and when we come to the final step that we can no longer either change the row or column because they are already in order, then we stop and we group the machines. Okay, so this is the brief introduction. So we're going to look at the example. Right, so in this example, we have different parts, their part number. Okay, so A112, A115, A120. So these are different parts. So in our table, these belong to different columns. Okay, so when we make column like these, okay, so A112 goes here, A115 goes here, and so on. Okay, so in the columns, and these are different machines, okay, different operations. So they go here. So we have saw 01, we have late, we have meal, and so on. Okay, so the operations or the machine goes in rows and the parts go in columns. And in the first step, that is what we do. Okay, and you can, so from this table, you can also notice that A112 uses saw 01, lathe 02, and grind 05. It does not use drill, it does not use mill, and so on. So for this part, where in the row and column set for a specific cell, if this machine uses if this part uses a specific machine, we assign 1. If it does not use, we leave it blank or 0. So for A112, we only assign 1 for SAW01, lathe 02, and grind 05. And we follow the same for all of these. Okay, so the first table we draw here, and here we can see from A112 up to 510, they are arranged in columns like this. So A112, A112, A115, A120, and so on. Okay, and then we write the machine. So SAW01, lathe 01, lathe 02, drill 01, and so on. So the machines here, parts here. And now we check. So A112 uses SAW01, lathe 02, and grind 05. So in SAW01, we give 1 for A112. For lathe 02, we give 1, and it uses grind 5. Okay, so this uses grind 5, and we give 1 for that. And we keep all of these other numbers 0 because this part only uses these 3 machines. So wherever it uses these machines, we assign 1, and otherwise 0. Okay, so for A115, it uses mill 02 and drill 01. So we choose mill 02 here and give 1, and drill 01 and give 1. Otherwise, we give 0, and so on. So the first step is to develop the table like this. Okay, so first arrange the parts and machines in columns and rows, and then assign 1 or 0 depending on whether that part uses the machine or not. All right, and if you look here, these are Okay, so these are Wj. Okay, so for this specific j, so this is j equals to 1, this is j equals to 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9, and 10. And this is I, so I equals to 1, 2, 3, 4, 5, 6, 7, 8. So now for this one, if we use this technique, okay, so for W1, so W1, what we do here is for W1, okay, which means j equals to 1, we are doing it for this. It is the sum of the binary weight of this column, okay? So first we have I equals to 1, so 2 to the power 1 times its weight here, okay? So 1 plus, so this is 0, so no need to do this, okay? You can leave 0. So for this, I equals to 3, so 2 to the power 3, right? So this is I equals to 3 times 1 plus, we do it for this, okay? So 2 to the power 7 times 1. And this is 2 plus this is 8 plus this is 128. Okay, so this is 138. So we get this Wi, and we do it for A115, which is for W2, for j equals to 2. So for j equals to 2, it starts from I equals to 4. So 2 to the power 4, because I is equal to 4, times 1 plus, we don't even have to do times 1, because for 0, we don't have to do this. And for I equals to 5, we have 2 to the power 5. So 2 to the power 4 plus 2 to the power 5, okay, this is 16 plus 32 is 48. And we have 48 here. All right, so we do the same for all of these columns until 10. And this is what we get. Now, in the next step, we arrange these parts in ascending order of this Wi, or it should be Wj. So that means number 6 is the smallest. So number 6 is A120, and it goes first. Okay. All right, and in the next step, yeah, A123. So A123 goes first. Okay, and these have the same Wi, so it doesn't matter. But we are keeping A120, so in a order, okay. And this is in increasing order. Okay, so the second step is to now arrange or make a new table such that the parts are arranged in ascending order of Wj. All right, so once we have this table, now we move on to this one where we now do the same for the row. So for I equals to 1, okay, this is 2, this is 3, 4, 5, 6, 7, and 8. This is 1, these are j, okay, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now for W1, okay, now we move this way instead of moving vertically. So we start with j equals to 1, so 2 to the power 1 plus 1 here, add number 2, so 2 to the power 2 plus 1 here, 2 to the power 3 plus 1 here, 2 to the power 4 plus 1 here, 2 to the power 5 plus 1 here, 2 to the power 9. So this is 2 plus 4 plus 8 plus 16 plus 32 plus 524. Okay. Sorry, 512. So if we add this 10, 30, 62, 74, so it will give us 574. Okay, so we get this. For the length one, for I equals 2, we only have 1 here. So for W2, we have 2 to the power 1, and that's it. Okay, all the other elements are 0. So just 2, and so on. So we keep doing this for all the elements. Sorry, for all I equals to these numbers, and we come up with these numbers right here. Okay, and our next step is to arrange these machines in the ascending order of this. So lathe 01 sits at the top, followed by mill 02, and so on. Okay, so in this step, lathe 01, mill 02, and so on. And now you can see, compared to our first table, the arrangements of the machine and the parts have changed. Now, if you count, or if you do the math again, so this might change. Okay, so our next step is to run the iteration again, like this. So for A123, if we calculate for the column once again, okay, we can see there is a 56 here. So this number should be after 48 here. Okay, so this part must be put here. Okay, so this is iteration 2. So we are following the same steps. We are calculating for a specific column now, and you can see here A112 should appear before 115. So before 115, okay, here. And now, since these have changed, okay, their position changed. And if their position changed, you can see these index, okay, these power are based on their position. And if the position changes, now their rows value also change. Because, okay, so this was I equals to 8 or 9 in the previous, sorry, j equals to 8 or 9. in the previous page, but here it is at j equals to 6. Okay, so 2 to the power 6 and 2 to the power 9 is different. So you might look at this 0 and say it is 0. Why does it matter? But for these, it matters, okay? So we run the iteration again. So we already did it for these columns. Now we do it for the rows. And once again, we come up with these new numbers and check if they are already in ascending order or not. And they are not. So this goes at the second, this goes at the third, this goes at the fourth, and then we have 128. Okay. So grind 05 should be at number 2. Let 02, SAW01, and so on. But compared to the first one, okay, so here, if we look at the first table and the arranged one, there, compared to this one, this has very little shuffling. So that means we are approaching our final steps. All right. And now you can see these are in ascending order. These are in ascending order. Okay. So these are just the binary position. Okay. So these are not the actual WI. Okay. So this is not the actual WI. All right. So these are just 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on. So finally, once we have this, like the final arrangement of the rows and columns, we will see something like this. Okay, and this is called the grouping. So how do we group? Right, so we want to leave, you can see, we don't want to include many zeros. Okay, so 0 means that machine is not used by that specific part. So if a part does not use a specific machine, why do we want to put them in the same group? If you are doing something with a milling machine and you will never use lathe machine, why do you want to put that part in the group where lathe machine is used? Does not make sense, right? So we want to avoid the zeros as much as possible. And the number of the groups, okay, we want to minimize, but we want to make sure that we don't try to leave one, and we don't want to include too many zeros in the group. And this is subjective, okay? So there are other ways to make a different group. But for this one, you cannot make this one group and this the other group. Okay, if they are together like this, put them in the same group. This is too bad, right? So you have, out of these 8 elements, you only have one element. So that means in one group, you have these different parts which never use this machine. And what is this doing? Okay, so none of these use grind. All right, so here we put like everything in one group. It's like I said, we cannot make a group like this and this. We cannot make group out of this. We cannot make group out of this. So on. Okay, so if there was 1, 1, 1 like this and 0 like this, you could have made this one group and this one the other group and this one the other group. So sometimes there will be exception like this. Okay, so this means if a part for a specific machine is out like this, so that means this part uses multiple machine, or the machine does multiple parts. So your final step is to build a table like this and try to include all the ones. Should be rectangular. Okay, so you cannot do a zigzag like this. Okay, so this is unacceptable. All right, so I think that's it for this video. I'll include the other contents in the other videos.